So it used to be the case, well, a long time ago in computing science, like many years ago now, that computing science students would learn how to parse stuff. So by parse, I mean read text from a file or from a string of some kind, and then extract information from the file or string. It used to be, like a very long time ago, it used to be one of the important problems in computing science. Right? If you wanted to write a compiler, you need something that can read the source code file. So if you take the compilers course, you might, maybe, learn a little bit about parsing algorithms. You probably don't see it anywhere else. It's generally considered more or less solved, right? So if you want to parse something, you basically download some library that parses it for you. Right? So many types of files they have some sort of formatting or structure, but they're not line-oriented files. Right? So programming languages are not line-oriented for the most part. Right? You can split lines in most programming languages wherever you like. Programming languages are generally more difficult to read. They're well beyond the scope of this course. There's a little link here. I'm not sure this link still works, but there's a link there that takes you to, introduces you to parsing algorithms. You generally need to know, it's generally easier to parse if you've taken a data structures course before. So if you know how to use stacks and queues and things like that. If you have line-oriented data, it's a little bit easier to deal with. So by line-oriented, I mean every line has a specific formatting, and generally all the lines have the same formatting. So you want to pull out some sort of structured information from each line. So there's this file called etc.password in Linux. I guess I should show you what it looks like. Okay, so this used to be the old, again, long time ago, this used to be where password information was stored for users. And so if you look at the formatting of the lines, so this is me, there's a username, there's a colon, and there's something here. In modern versions of Linux, this is always X. That used to be your password. It used to be stored in plain text. So anybody who knew where etc. password was, you just look in here and you see the password. That's a user ID, that's a group ID. Here there's a bunch of missing information. Oh, sorry, wait, comma. No, there's not. There's some information here. That's your home directory. That's your default starting shell. So if you log into, when I log into Linux, I get bash as my starting shell. Notice here that the fields are separated with colons. So there's an example of a file that has formatted or structured data. So that file is plain text, 1 record per line. Each record has 7 fields separated by colons. Right, so there's an example record, again explaining all of the pieces of information. That middle field here is called the GCOS field. I don't remember what GCOS stands for. You can put whatever you want there. Generally, there's nothing there, or there might be your contact information or something like that sitting in that field. The fields are not allowed to contain a colon, because the colon is used as the separator here. Right. Okay, so there's a bunch of ways that you can read this file. One of the ways to read it is with this function called strtok, which is a funny function. We haven't seen this one yet. So let's take a look at what this thing does. I probably had the documentation for this a while ago and don't have it anymore. Is it here? It's not here. All right. That's not the one I want. CPP. All right, let's take them. So strtok, it's one of the standard library functions. It's defined in the string or declared in the string header. It's the string tokenizer function. It's very unusual as far as standard library functions go. So you pass it in a string, and you pass it in a second string. The second string is the string containing the delimiter characters. So these are the characters that you want to consider as separating the fields. And it returns a single string at a time. So this thing doesn't break up a string into individual tokens. It gives you back the tokens one token at a time. One token or one field, same thing, right? So it splits it up one field at a time. So what this means is to extract all the fields, you have to repeatedly call this function. That in itself is unusual, right? So the first time you call the function, this is also very unusual, right? The function expects a C string as argument for str, right? So that's the string that you're going to parse or try to extract the information from, right? So the first time you call the function, you pass in the string you want to extract the characters from, right? Any other time you call the function, including the first time, right, you always pass in the string containing the delimiter characters, right? So the characters where you want to use as separator characters. The unusual thing about this function is that you can change the delimiters between fields. So if your first delimiter is a colon and then later on it's something else like an exclamation mark, you can switch the delimiter. That's also unusual for these types of parsing functions. All right, so the first time you call the function, you pass in the string you want to split up, you give it the delimiters, and it starts at the beginning of the string. Right? So it's going to start looking at the first character of the string. Now, the next time you call the function, so to get the second token, you call the function, and this time you pass in null for the string, right? Which is unusual, right? So what it's going to do is it's going to continue reading the string that you passed in the previous time you called the function, right? So first time you pass it null, every other time after, first time you pass it the string you want to parse, every other time you pass in null. And so what does it do? So after it extracts the first token, it remembers what string was it. Basically, it remembers a pointer into the string where it stopped reading from. Right? So when it finds the first delimiter, it keeps on searching until it finds the next delimiter character, and then it remembers that pointer in the function itself. So that's a bit unusual. So we have a function that can actually remember stuff. Does anybody remember how a function can remember stuff in C? Anybody? Okay, that's a good test question. That's a good exam question. How does a function remember stuff in C? So basically you use a static variable inside the function, right? So remember, static variables retain their value between calls to a function. So there's a little static variable that contains a pointer. There's a static variable that is a pointer type. So the function can remember where did it leave off after the last time the function was called. Okay, so basically what this thing does is it marches through the string looking for delimiters, right? So it starts at the front of the string the first time you call it, marches through the string and looks for a delimiter. When it finds the delimiter, it keeps on going until it finds the next non-delimiter character, and it remembers that position, right? Now, also whenever it finds a delimiter, it erases the delimiter and replaces it with \0. So the function is unusual in that it is also destructive, right? It destroys the string that it's parsing, or it modifies the string that it's parsing, right? It replaces the delimiters with \0, right? And so the first time you call the function, if it finds a field, right, it returns a pointer to the beginning of the string, right? And now there's a \0 where there used to be the first delimiter. So when you use the string with any of the standard library functions, it reads the first field and then it sees a null terminator and stops, right? So it plays the trick of inserting null terminators into the string to separate out the tokens. All right, so the next time you call it, you pass in null, it remembers where it left off, so that's the start of your new string that it's going to return, marches through the string, looks for a delimiter, replaces it with a null terminator, and then keeps on going until it finds the next null terminator. So it's a very weird function, right? The way you call it is different every time you call it, right? When you want to start parsing a string, you pass in the string. When you want to parse the remaining fields of the string, you pass in null. You can change the delimiters, and the function nukes your string, right? It inserts null terminators all over the place. Oh, that's not what I want. Okay. So if you want to parse this thing using strtok, where to go? Sorry. I pulled this all up last lecture and then lost it. Oh, that's not it either. Oh, is this it? Okay. Oh, bash is dead too. All right. What did I call this? What did we call it over here? Oh, sorry. Here? No, not here. So I'm looking for the name of the file. C password, okay. Okay. There we go. All right, so if I want to parse that the password file, I need something to store all of the individual fields in, right? And all of the fields are different. So some of them are ints, some of them are strings. Well, most of them are strings, but some of them are ints. So it's useful in this case to create a little structure to store all the information in. So I created a structure called record, and I'm going to store the username, the password, the IDs, and the other strings in this record. Notice that I'm using, so I'm using pointers here. I'm not using arrays of char. You could use arrays of char, but you'd have to assume how big each array is. So I'm going to use pointers, which means I'm going to have to dynamically allocate memory to store these strings. Right? So because I have to dynamically allocate memory to store the strings, and I want to copy the strings from the file, it makes sense to make a little function that can copy a string and allocate memory for the new string that you've just copied. Right? It's easy to do. Right? So that's the source string. Right? I want to store the results in a new string and return the new string back to the caller. So I guess the regular way you would do this is just you would return a pointer to a string here. Right? You would return a pointer to char here. I've chosen to do it a little bit differently here, so that you can use you can see the use of a pointer to a pointer. And so the idea here is that we're going to read the file, we're going to extract the data. I want to store the data from the file in that string right there, right? So I want to extract the username from the file. I want to store it into this string here. The problem is that's not a string yet, right? It's just a pointer to something. So I need to make this point at something else, right? I need to change the value of the pointer, right? So for the function to change the value of a pointer, you need to pass it a pointer to a pointer. So that's why that's star star, right? So we're going to allocate memory, right? Make that pointer dest point at the new pointer, right? So find the length of the string to copy. So just use string length in this case. Right? Allocate some memory. So I need at least length characters +1, right? Again, +1 for the null terminator. Where am I going to store the pointer? Well, I'm going to store the pointer in, well, you kind of want to store it in dest, but you have to remember dest is a pointer to a pointer, right? So you dereference dest, right? And store the value there, just like you would store in int, right? If someone wanted someone wanted a function that changed one of their ints, they would pass in a pointer to an int, right? Inside the function, you would dereference the pointer, store the value in the dereferenced object that the pointer points at, right? So it's the exact same thing here. It's just that the object that we want to write into is also a pointer, right? Thus, star star. Okay, so once you've got your pointer, or you've allocated some memory, you can go ahead and copy the string into the destination, right? Again, dereference dest because dest itself is a pointer, right? Sorry, dest itself is a pointer to a pointer, right? I want to get the thing that dest is pointing at, right? The memory that dest is pointing at, so dereference dest here, right? Copying the source string. So to parse a record, I'm going to pass in a string, so that's a string containing one line from the file. Right, we're going to parse the record and we're going to return the record back to the caller. Right, you don't need a pointer to a record here. Right, we can just pass around one of these things just the way it is. If you wanted to pass around pointers to records, you could, right? But there's no need to do so in this case, right? So make a record, R, right? So remember when you make a struct object, all of the fields are uninitialized. So we have to be careful not to use the members right away, or we have to be careful not to use the members until we've assigned them a value. All right, so we're now going to start to parse the string, and we're going to use strtok to do it. So the first time you call the function, you pass in the string that you want to tokenize. You pass in the delimiter. So here we're only using colons, right? If that returns a string, then if that returns a non-null pointer, then it's pointing to the first field in the string, right? If it returns a null pointer, then it doesn't find the field, right? So it doesn't find a null term, a token in this case. Right? So when you're using this function, you're always checking the return value, right? If it's null, then it didn't find a field, right? So if it's null, we can just return R. Whoever gets back R is going to get back a structure where nothing is valid. Right? If it's not null, then we've got a string. So we can copy the string, right? I want to copy it into the record, and I want to copy it into that member, right? So I need an address to the member of the record, right? Because remember, we're passing in a pointer to a pointer whenever we copy a string, right? So we pass in the address of our username. That makes a new string for us, right? Assigns our username to point at the new string, and the string has the copied contents of str. And now you keep on going, right? Now the next time you call the function, you pass in null, because strtok remembers where it left off in the previous string, right? And now it's just the same thing all over again, right? Check if the return value is null. If it is, there's no password field, right? So return the record as it is. So all the other stuff is uninitialized, right? If you read in a password, go ahead and copy the string. Right? For the user ID, that's a number. So to parse the number, we don't have to do anything, we don't have to call our own function here, right? I can just use a to I, right? A to I converts the string to an integer if it can, right? And then we can just store the value directly into the UID member of the record. Right? GID is also a number, so it's the exact same thing, right? Sorry. Convert the result returned by strtok into a number stored in the GID field, right? And then the rest is just a bunch of strings, right? So a string, and another string. If we get to the end, we've managed to read a complete line from the file, right? Then we can print the record. This is just straightforward use of printf, right? So just print the username as a string, print the IDs as unsigned ints, right? And then our little main function, we open up the file right there, right? If we can't open the file for some reason, either it's not there or it's not readable, right? That's an error, so exit from the program in this case. Make a pretty huge assumption here. So I'm going to assume that each line of the file is no bigger than 99 characters long, right? 99 because I need one for the null terminator. And that's true for my password file. It may not be true in general. Right. And now just read the file one line at a time. So to read a file one line at a time, it's just fgets, right? Or fgets is one way that you could do it. Right. So call fgets, right? Tell fgets don't read more than 99 characters at any one time, right? Read from the file f, store the results into the buffer buff, right? Now parse the record, print the record. Don't forget to close the file when you're done. I guess we really should return 0 at the end. Okay, so what the heck happens when we run this program? All right, well, it looks like there's something weird happened. Right. So if you scroll through the output, right, it looks like it read root okay. So there's the username for root, password's always X. Those are the correct IDs for root, right? And all the information here looks fine, right? That looks fine, that looks fine. Everything looks fine so far. Somewhere it barfs. there's only one user on this computer. So notice that Linux creates a whole bunch of users for a bunch of different services. Where does it, oh, it's gonna, right there, something happened. Right, so something weird happened here, right? Something weird happened here, right? That also looks a bit weird. Although maybe not. Something weird happened here. Same with the shell, right? Something funny is going on. All right, so what the heck is going on? So here's an example. So the formatting for the password file doesn't say anything about it doesn't say that a field has to be present. So you can have missing fields, like right here, right? So here there's a colon, then a colon. Whatever was supposed to be here, that information, that field is not present, right? So the way string tokenizer works is it starts at the front of the string, right? It marches along until it finds a colon, or the separator, right? Continues going until it finds the next non-delimiter, so it gets to the x and it stops. So it's going to remember a pointer to that x, right? When it sees that delimiter, it replaces it with \0. So there it is replaced in the result, right? And then it returns a pointer to the start of the string that it was given originally. So the first time you call this function, the string is jsmith, right? All the other information is still here, but because that null terminator is sitting there, any of the standard library functions think that the string is just jsmith. Right, next time you call the function, it picks off from where it left off, so it picks off from the x, right? Reads until it sees a colon, so there it is. Goes to the next non-colon character and remembers this is where the next string is going to start, right? Returns a pointer to the x, erases that colon with a null terminator, right? So after you've parsed 4 fields, you get to here, right? The next field here is supposed to be a string, right? So now it keeps on going, right? And s is now here. So it reads in the string 1000. It doesn't read in the unsigned int, right? It reads in the string. Sorry, reads in that, right? That reads in the unsigned int correctly, right? But the next time, once it erases that delimiter, it gets to here, right? It continues going until it finds the next non-delimiter, so it goes to here, and it's skipped over the previous field completely. And so the next thing it reads in is the user's home directory instead of reading in, that's the gcos field, right? So it skips over reading the gcos field and instead reads in the home directory. So string tokenizer, it can't deal with empty fields, right? And what ends up happening is if you have an empty field somewhere in your string, you end up calling string tokenizer too many times, right? And eventually you end up with a bunch of null, getting back a bunch of null results for your fields, right? So this fails when there's an empty field. You can try to get around this. You can try to work around it. So password2.c, there's a slightly more robust version of this. So I guess it's worth looking at that. This is probably not gonna, sorry. All right, so what is this? So everything's the same as before. Now we're going to have a little function that tries to test if a particular field is empty. All right, so how are we going to test if the field, oh, sorry. All right, so remember we have this function here, so let's see how we're going to use this. So we're going to look at the name, then the password, user ID, group ID, and then we get to here. Okay, so we're now going to try to look ahead and test if the gcos field is empty, right? So how are we going to do that? Okay, so we're going to pass in str. So remember, str is no longer the original string, right? It's where strtok left off on the previous call, right? So it's now pointing at, it now may be pointing at a colon, right? That's what we want to look for, right? All right, so we're going to first test the length of the string, right? That we're pointing at, right? Now remember what this thing has done, right? It's written in a \0 somewhere, right? So we're going to look for the character after the end of the we're going to look for the character after the end of the string, right? So the character after the end of the string is at length +1, right? Because remember, at length it's the null terminator, right? So we want to now look ahead and see if there's a colon sitting there. If there's a colon sitting there, we know that the field is empty, right? And so that handles that case there. So if it's empty, right, we know that the G-cos field is empty. If it's not empty, we can go ahead and read the G-cos field, right? If it is empty, we'll just write the empty string into the G-cos field. And away you go. The rest of it's all the same, right? So run that one. Right. And you can see now we've successfully gotten to the end of the file, right, and read in everything correctly. Right. So you can sort of work your way around the fact that string tokenizer can fail. But you could also choose to do this approach the problem in a different way. Right. So instead of using strtok, right, you can use any one of your scanning functions. Right. So fscanf if you want to read the file directly. scanf if you want to read the file one line at a time and then look at the strings that you've read in. Right, so remember what fscanf does, right? It takes a string and it tries to extract information from the string, right? It tells you the number of tokens that it has successfully converted, right? So for the password file, you might consider, right, reading in this string, and then trying to read in, say, a string followed by a colon, followed by a string, followed by a colon, followed by a number, followed by a colon, followed by a number, followed by a colon, followed by a string, maybe, followed by a colon, followed by a string, followed by a colon, followed by a string, right? The problem with scanf is if you try to read in a string, right, it stops reading when it hits a space. Right, so scanf will also get defeated by the G-cos field or any other field that happens to have a space in it. If you're getting the idea that reading stuff from a file is hard, it's because it is. Right? It's extremely hard to robustly read stuff from a file. Okay, sorry, what time do we have here? 11:12. All right, so I don't want to go too much into detail. I don't want to go into too much detail into this. I'm not going to ask you this on the exam anyway, right? But if you ever find yourself in a situation having to do something like this in C, you have to remember that there are other conversions, right? So most of the scanf conversions simply ignore space, right? So if you start to read in a number, if you want to read in a number, it just skips over all the white space and then reads in the number. Right. If you want to read a string, it reads stuff until it finds a space. If you want to be able to read the string, if you want to be able to read a space, you have to go character by character, or you have to use this other conversion, which we haven't seen yet. So the square bracket conversion. Right. So remember that most conversions consume and discard all leading white space characters, and they end when a trailing white space character is found. Right. If you need to deal with white space, %C and square brackets is probably what you're looking at using. Right. If you're reading in strings, don't forget there's another problem, right? If you're going to read in a string, you have to read it into a buffer, into an array somewhere, right? So you want to avoid reading in a string that's too long. So you can always specify the maximum field width with these specifiers, right? So if you're reading in a string, you can say 10s. Right, and that will only read in at most 10 characters. Similarly, the C is weird, right? It doesn't read in just one character. If you say 10C, it'll try to read in 10 characters, I believe. Right. Okay. So remember, if you're going to use %s, the array where you're storing the result in must have at least width plus 1 characters, where width is the maximum field width. right? So if you say %10s, make sure you're reading into an array that's at least 11 long, because it needs to write the null terminator into the array. The square bracket conversion matches any non-empty sequence of characters from the set of characters, right? So square bracket ABC, that'll match any non-empty string made up of the letters A, B, or C, right? So ABC, AAA, AB, CBA, it'll match all of those, right? If you know what characters you don't want to match, use the caret, right? So caret set matches everything that's not in that set. Right, so not ABC matches any non-empty string that does not have an A or B or C in it. Right. What else is going on with it? There's something else that's funny happening with this GCOS field. No, never mind. Oh, the GCOS field can be quoted. It's not here, sorry. You are allowed to contain quotes in these fields. So quoting screws things up too. Right, so if you have a quoted string, to match a quoted string containing white space, right? You can't use %s on its own because %s stops when it sees the white space, right? So if you want to read in a quoted string, the way you do it is that's your specifier, right? And you look at that thing and say, what the heck is that? Right? Okay, so it's a string, so we have to quote it on the outside, right? Now you want to read in a quoted string, so that means you want the quote to be part of the string, right? You can't make a quote a part of a string. The quote delimits the start and end of the string, so you have to escape the quote, right? This isn't a bash thing, right? Every operating system has this issue, right? So escape that quote and escape the quote at the end, right? So this means it's going to try to read in a string that's quoted, right? We want to read in spaces as part of the string, so I can't use %s. Right? But what you can do is you can use the square bracket notation, right? And so to read in a quoted string, you want to match the start of the string, the starting quote, the ending quote, and everything in between should not be a quote, right? Notice that you have to escape the quote again. So not / quote, so not a quote. So that'll read in any quoted string containing white space. If you ever find yourself reading in information from a file, especially something called a comma delimited file, which is the text files that most spreadsheets will spit out for you, including what OnQ gives me, right? So if I want to read the spreadsheet that OnQ gives me in a separate program, it quotes a lot of stuff in it. So you have to deal with that when doing that sort of thing. Right? So this explains what what this formatting string is doing. Right? Match the opening double quote, match any sequence of characters that does not include the closing double quote, and then match the closing double quote. Right? And so I will post these on OnQ sometime if you want to see these, so that you can see an example of using scanf to read the file. Yes?
Can you use scanf to like find a string that is together? Like if ABC only read ABC separately, but can you not read it so that it does A and B?
Sorry, run that by me again. I don't understand what.
Can't scanf look for a string that is like together instead of each individual character?
That is together. So what do you mean together exactly?
One of the examples is that it only read ABC separately, but can it read the string together?
Here?
Yeah.
No. So that right there will match any non-empty string made up of the letters A, B, or C. It's not A, B, and C. Like any string made up of those, any one of those letters, any one or any combination of those letters will be matched. Okay. Yeah.
Is it possible to make it so that it only reads a combination?
Only a combination. So what do you mean by only a combination? Like it has to have an A, it has to have a B? No, there's no way to do it with scanf. So to do that, you have to read in the string, and then you have to do further processing of the string and decide whether or not it's valid. Okay. Yeah. There's a limit to what they can give you in the library, right? They can't anticipate every possible parsing situation. All right, any other questions? All right, so I think Thursday will be the last lecture. So on Thursday, I'll tell you what the exam's gonna look like. We might go over some old exams, and then we'll wrap this thing up and put it to bed. All right.